All right, so get this. We're diving into a software design principle today, and it's all about elegance and efficiency. It's called composition over inheritance. Think of it like you're choosing Legos over a giant pre-built model, right? You get way more flexibility and creative freedom that way.
Yeah.
And that's exactly what we're going to unpack. You've shared some great material, a breakdown of this principle, its key elements, and even real-world code examples in different programming languages. It's going to be great.
Well, and what's really fascinating about composition over inheritance is how it kind of shifts our focus, from these rigid structures to building systems from smaller independent components.
Oh, interesting. So instead of like extending a base class and inheriting everything, we're creating a system from these more independent building blocks.
Yeah.
Kind of like constructing a house, right? Brick by brick. Each brick has its own specific purpose, as opposed to like trying to modify a prefabricated structure that might not fit your need.
Yeah, that's an excellent analogy. And that approach, it comes with some significant perks. For instance, flexibility and modularity are key.
Okay, yeah. Because if you need to make changes down the road, you're not stuck with a rigid structure. You can easily swap out components, add new ones, or modify existing ones without causing like a ripple effect throughout the whole system. It's like having those Lego pieces that you can rearrange as needed.
Exactly. And this leads to reduced coupling, which is a major win for any developer. Since the objects are loosely connected, there are fewer dependencies to worry about. So you're less likely to encounter that dreaded domino effect of bugs when making changes.
That sounds like a lot less stress for the developer. I'm guessing this also makes testing a whole lot easier, right?
Absolutely. With independently testable components, you can isolate each part of the system and verify that it works correctly on its own. This leads to more reliable code, which is especially important for, those larger, more complex projects.
Yeah, I bet. And I imagine this modularity makes the code much more reusable too, right?
Precisely. You're working with these smaller, focused components that can be reused in different parts of your application or even in entirely different projects. Write the code once, leverage it multiple times. That's efficiency.
That's the dream. So far, we've got flexibility, reduced coupling, easier testing, and greater reusability. But I'm also seeing some other advantages listed in the material, things like behavioral changes at runtime and better alignment with the single responsibility principle. Can you elaborate on that a bit?
Of course. The single responsibility principle advocates for each part of your code to have one specific job, making it easier to understand and modify. Composition aligns really well with that. As for behavioral changes at runtime, composition provides the flexibility to modify how objects behave on the fly, which is essential for dynamic applications.
Okay, this is all making a lot of sense. Now I'm curious how this principle works across different programming paradigms. Is it mainly an object-oriented thing?
Well, while it's common in OOP, composition's core concept transcends specific paradigms. We see it in front-end frameworks that heavily rely on component-based architectures. Even in functional programming, composing functions can achieve similar goals. It's a pretty versatile concept.
Okay, that's really interesting. It's not limited to just one way of coding. Now let's dive into those real-world examples. You've got Java, Python, JavaScript, and Swift lined up for us. Let's start with Java.
Sure. The Java example demonstrates a notification system built with composition. It uses separate classes for each type of notification: email, SMS, push notification, and so on.
Gotcha. So instead of a rigid inheritance hierarchy, we have independent classes for each notification type.
Yeah. Right. And there's a notification sender class that contains instances of these different notification types, essentially composing the functionality it needs from these individual pieces. The beauty of this is, if you need to add a new notification type, say a Slack notification, you create a new class and plug it into the notification sender. Without touching the core code, flexibility is baked right in.
That makes sense. Now, what about Python? How does composition play out there?
Well, Python's dynamic typing makes composition quite elegant. In this example, any object with a send method can work with the notification sender. It doesn't matter what type of notification it is, as long as it can send the notification. This highlights the power of what we call duck typing.
Duck typing. So if it walks like a duck and talks like a duck.
Exactly, it's a duck. We're focused on the object's behavior rather than its specific type. This makes Python very adaptable when it comes to composition.
That's a great illustration.
Yeah.
All right, let's move on to JavaScript. It's known for being flexible, so I'm guessing composition fits in nicely.
You guessed right. JavaScript allows for composition through functions and object literals. The example you provided showcases a notification system where the sender is a function that takes in an array of notification objects. This allows for a very concise and modular code structure where you can easily add or remove notification types as needed.
Okay, so again, it's composing its functionality from these independent parts. Last but not least, let's talk about Swift and how its protocol-oriented approach works with composition.
Sure. Swift is a great example of how protocols can enhance composition. In the provided example, there's a notification protocol that defines a send method. Any class that wants to act as a notification type needs to conform to this protocol.
Okay, so you have your different notification types like email notification and SMS notification, each conforming to that protocol.
Precisely. And the notification sender works with an array of objects adhering to the notification protocol, composing its functionality by leveraging those shared behaviors.
It seems like no matter what language we're talking about, composition provides a consistent set of benefits, increased flexibility, modularity, and much easier maintenance. It's really interesting to see how this principle can be applied in so many different ways.
That's the beauty of it. It's a fundamental principle with broad applications. Yeah, it really highlights how this concept can be adapted to fit different programming styles and languages.
It's like having a universal tool in your developer toolkit, you know. Seeing these concrete examples really brings it all home. But let's step back and look at the bigger picture for a moment. Why is composition over inheritance so important? How does it impact developers and anyone working with complex systems in the real world?
Well, you know, when you look at the broader implications, composition over inheritance allows us to create systems that can adapt to change much more gracefully. The world of software, and really the world in general, is constantly evolving, right? Requirements change, new technologies pop up, user needs shift. And with composition, we're better equipped to handle those changes without having to, rewrite everything from scratch.
So it's like having a toolbox full of specialized tools that you can mix and match.
Yeah.
Rather than one giant do-it-all gadget that's clunky to use and even harder to fix when something breaks.
That's a great way to put it. And this adaptability is critical for building software that's easy to maintain over time. Imagine trying to change a massive code base built on a rigid inheritance structure. It's like a house of cards, one wrong move, and the whole thing could come crashing down.
So you don't want that. So composition helps us avoid that precarious situation and create code that's more robust and manageable in the long run.
Exactly. And this has ripple effects on the health and sustainability of software projects. It means faster development cycles, fewer bugs to squash, and ultimately a better product for the end user.
Right. Now, this brings up an interesting question. If composition is so beneficial, why don't we see it used all the time? Is there ever a situation where inheritance might actually be the better choice?
That's a great point. And it's important to acknowledge that inheritance still has its place in software development. When you have a very clear is a relationship between objects, like a car is a type of vehicle, and you want to share core functionality in a hierarchical way, inheritance can be a suitable approach.
Yeah, those classic examples of inheritance hierarchies we learn about. So it seems like it's not a black and white situation.
Precisely. The key is to be aware of the potential drawbacks of creating deep inheritance hierarchies. They can become quite rigid and difficult to manage. It's crucial to step back and ask if composition might offer a more flexible and adaptable solution for your particular scenario. It's about choosing the right tool for the job, as you mentioned earlier.
And I think what you're highlighting, the importance of critical thinking in software design.
Right.
It's not about blindly following one rule or another, but about understanding the trade-offs and making informed decisions based on the specific needs of the project.
Absolutely. That's something I appreciate about the material you shared. It presents composition over inheritance as a powerful principle, but not a silver bullet. It emphasizes the benefits while also acknowledging that inheritance still has its place in certain situations.
Yeah. It's all about having a diverse toolkit and knowing when to use each tool effectively. And I think that's a valuable takeaway for our listener, regardless of their technical background. This principle encourages us to think more critically about how we approach complex problems, whether it is building software or designing any type of system in the real world.
And even beyond the technical aspects, the core idea of composition breaking down complexity into smaller, manageable parts can be applied in many areas of life.
That's a fantastic point. It's almost like a mental model for approaching any kind of challenge, wouldn't you say?
Exactly. Think about writing a book, for example. You wouldn't try to write the whole thing in one go. You break it down into chapters, sections, paragraphs, those smaller self-contained units that you can then compose into a coherent whole.
Right. Or even planning a big event, right?
Yeah.
You break it down into manageable tasks, delegate responsibilities, and then orchestrate it all to create the final event.
Precisely. It's fascinating how this principle can be applied in so many different contexts. It's not just about software. It's a way of thinking that can help us navigate complexity in all aspects of our lives.
Okay, let's bring it back to software for a moment. We've talked about the benefits of composition over inheritance, the real-world examples, and even its broader implications. It's been a great discussion. As we wrap up this part of our deep dive, what's one key takeaway you'd like to leave our listener with?
I think the most important message is this. Understanding composition over inheritance isn't just about memorizing definitions or code snippets. It's about internalizing a way of thinking that leads to more flexible, maintainable, and ultimately more elegant solutions. And that's a valuable asset for anyone working with complex systems, whether in software or any other field.
I love that. It's not just a rigid rule to follow. It's a way of thinking, a mindset that can empower us to tackle challenges more effectively. Now, you mentioned that this principle has applications beyond software. I'm curious to hear your thoughts on that. Where else do you see this idea of composition leading to more adaptable and elegant solutions?
That's a great question. And it really gets to the heart of what makes this principle so intriguing. It goes beyond just technical concepts. It's a fundamental way of thinking about complexity itself.
Right. It's all about breaking down large, complex problems into smaller, more manageable pieces, and then figuring out how to combine those pieces in creative and flexible ways to achieve your goal.
Exactly. And we see examples of this everywhere. Look at the natural world. Ecosystems are a perfect illustration of composition in action. They consist of countless individual organisms, each playing a specialized role, all interacting and interconnecting to create a complex and incredibly resilient whole.
Yeah, that's such a great example. It really highlights how composition can result in systems that are not only adaptable, but also incredibly resilient. Even if one part of the system is disrupted, the other parts can often compensate and keep things functioning smoothly.
Exactly. And we can take that same line of thinking and apply it to human organizations, social structures, even economic systems. Really, any complex system we encounter can benefit from this approach.
So it seems like this principle has a lot of potential to improve the systems we build and interact with in various aspects of life. It's not just confined to the realm of software design. It's a way of thinking that can help us understand and navigate complexity in all its forms.
Absolutely. It's about recognizing the power of breaking down challenges into smaller, more manageable components, and then finding creative ways to combine those components to create a more robust and adaptable whole.
This has been such an insightful conversation, and I feel like we've only just scratched the surface.
Yeah.
Of what composition over inheritance has to offer. As we wrap up this deep dive, I'd love to hear your final thoughts on what our listeners should take away from this discussion. What's the one key message you want to leave them with?
I think that the biggest takeaway is this. Understanding composition over inheritance isn't just about memorizing technical definitions or specific code implementations. It's about embracing a new way of thinking, a mental framework that can help you approach complex problems with more flexibility, creativity, and resilience. And those are valuable skills to have, no matter what field you're in.
I couldn't agree more. It's about shifting your perspective and seeing the world through a new lens. One that emphasizes modularity, adaptability, and the power of building things up from smaller, well-defined parts.
Exactly. And the exciting thing is that this principle is still evolving as new programming paradigms emerge. And technologies continue to advance, I think, we'll see even more creative and innovative applications of composition over inheritance in the world of software and beyond.
It's like this principle has a life of its own, constantly growing and adapting.
Yeah.
alongside the ever-changing landscape of technology and problem solving.
Absolutely. And I think that's a really encouraging thought. It means there's always more to explore, more to learn, and more ways to apply these principles to create more elegant and effective solutions.
Well said. So to our listener, we encourage you to continue exploring composition over inheritance and see where it leads you. Look for ways to apply it in your own work and your personal projects, even in the way you approach everyday challenges.
Don't be afraid to experiment. Try different approaches. See what works best for you. And most importantly, never stop learning and challenging yourself to find better, more innovative solutions.
That's a fantastic note to end on. Thanks for joining us for this deep dive into composition over inheritance. Until next time, keep exploring, keep questioning, and keep composing.